Hello everyone, myself Professor S.K. Sonone from Kekewa College of Agriculture, Nasik, Department of Plant Pathology. Today's presentation topic under the course MIBO 111 Introductory Microbiology, and today's presentation topic is biofuels. So, what is meant by biofuel? Definition of biofuel: a type of fuel whose energy is derived from biological carbon fixation, or fuel which is produced from renewable biological resources such as plant biomass and treated municipal industrial waste. Why to use biofuels? Fossil fuels are limited to reduce dependency on fossil fuels, to reduce reliance for an oil, to lower emission of greenhouse gases, and to bring business to rural economics. Advantages of biofuel: there is no emission of hazardous gases, locally available in every region, eco-friendly so they do not cause any global warming, energy release per unit mass of biofuel is greater than the energy release from the unit mass of fossil fuels. Types of biofuel: first generation biofuel, second generation biofuel, and third generation biofuel. So, first generation biofuels are made up from sugar, starch, and vegetable oil. Second generation biofuels made from non-edible plants like jatropha. Then third generation biofuels made from algae of microbes. For some examples of first generation biofuels, that is biodiesel, biogas, syngas, bioalcohol, and vegetable oil. First one, biodiesel, produced from oil or fats using transesterification after mixing biomass with methanol and sodium hydroxide. For example, palm, coconut, jatropha, rapeseed, mustard seed, sunflower, soybean, animal fats, and algae. Advantages of bio: it is called as clean fuel. It does not contain carcinogens. It possesses high biodegradability and lubricating property, improve engine efficiency and operating life cycle. Readily mixes with petroleum diesel fuel in any ratio. Safe in transport and storage. Disadvantage is high production cost. Biodiesel is more likely to attract moisture. That's why this is the important disadvantage of biodiesel. Then bioalcohol, biologically produced alcohols, it is called as bioalcohols. For example, ethanol synthesis. Bioalcohols are produced by action of microorganisms and enzyme through the fermentation of sugar and starch, used for vehicles. Syngas, gaseous mixture of CO2 and H2. It is produced by partial combustion of biomass. This gas is produced after combined process of gasification and combustion and pyrolysis. Application: for used to produce methane and H2, used to generate electricity. Then biogas. Biogas is the mixture of methane, hydrogen, and H2S, nitrogen, produced from anaerobic digestion of animal plant waste. This is the definition of biogas. Biogas is produced in three stages. First, hydrolysis, acidogenesis, and methanogenesis. Hydrolysis means where enzyme degrade complex carbohydrates, proteins, and lipids. Then acidogenesis, hydrolysis produce are converted into acetic acid, hydrogen, and CO2. Then methanogenesis, when obligate anaerobic bacteria control methane production. Then takes place methanogenesis. So, biogas production plant, two types of biogas production plants, that is fixed dome and floating dome. So, some bacteria involved in the biogas production, that is bacillus, Methanocercina, methanobacterium. Optimum pH for methane production is 6.8 to 7. 2. Next, this is the biogas production plant, and this is fixed dome biogas production plant. An equal quantity of waste means plant and animal or industrial waste and water is mixed to the process prepared slurry, and this slurry is prepared in mixing tank. Okay, this brown color is mixing tank. This is mixing tank. Through the inlet, that is sloping slurry is inserted into digester. Sloping slurry is insert into the digester. This is mixing tank, then primary digester. Slurry inserted into digester. When digester is partially filled, okay, this is partially filled with the slurry, introduction of slurry is stopped and plant is left unused for about 2 months. During this period, fermentation, decomposition takes place by anaerobic bacteria. As a result of anaerobic fermentation, biogas is formed and get collected into the dome. As more and more biogas start collecting, pressure exerted by biogas forces slurry into the outlet. This is the biogas collecting into the pressure into the dome, this brown color dome. From outlet slurry overflow, this is overflow into overflow tank. Slurry is removed and used as a manure. This slurry end product is used as a manure and biogas for electricity, or we can say use in the kitchen also. So this is the biogas production plant. Next, this is the procedure we already tell you. Thank you very much, and read carefully, listen carefully this video and this biogas production plant and their procedure is very important for final examination, and always every year this question asked for the 4 marks as a short note of biogas production. Thank you very much.